Hello dear learner, I Dr. Tarkeshwari Verma from CSV2 welcome you in this massive open online course of Fundamental of Engineering Physics. In a previous lecture, we studied about the definition of the laser, their different type, working principle and its application. In this lecture, we study about sounds and ultrasonic sounds. Sound is the form of the energy that travel through the one medium to another medium in a form of the mechanical waves. It is produced when an object vibrates, creating compress and refraction in the surrounding medium. These vibrations propagate away from source in form of the wave, which are detected by human hearing, typically in the range from 20 Hz to 20 kHz. Sound above this range is called ultrasonic and below this range is called infrasonic. Sound have some special characteristics. First characteristic is the frequency. Frequency refers to the number of the vibration or cycle that a sound wave completes in a 1 second. It is measured in a hertz. Second characteristic is the wavelength. Wavelength is the distance between two continuous points in a same phase on a wave. Wavelength is inversely proportional to the frequency. Higher frequency sound have shorter wavelength and longer frequency sounds have longer wavelength. Amplitude that refer to the maximum displacement of particle in the medium from their rest position due to the sound wave. It represents the wave energy. Greater amplitude result in a louder sound, while smaller amplitude result in a softer sound that measure in a decibels. Next characteristics is the speed. The speed of the sound depend on the medium properties such as the density and elasticity. For example, sound travel faster in a solid than liquid and faster in a liquid than gaseous phase. Next characteristics is phase. Phase refer the position of the point in the time a wave cycle. It is typically measured in a degree, with 360 degree representing a full cycle. When two sound waves of the same frequency are out of phase, they can interfere with each other, leading to constructive or deconstructive intensity. That is amount of the energy of sound wave carries per unit area perpendicular to the direction of the wave. It is the proportional to the square of amplitude of the sound wave. Sound intensity is measured in a watt per square meter. Reflection is the also one another characteristics of the sound. Reflection of the sound occurs when sound waves bounce off a surface. This can result of echoes, revibration or change of the direction of the sound waves. Refraction occurs when sound wave changes direction as it passes from one medium to another due to change in the speed of the sound a different medium. This phenomena can be observed when travel from air into water or when temperature gradient causes sound waves bend in atmosphere. Diffraction. Diffraction allows us to hear sound when the source is not in a direct line of sight. Such is the hearing someone speaking from around the corner. Next, our characteristics point is absorption. Absorption occurs when the sound energy is taken up by material, converting it into heat to another form of the energy, thereby reducing the sound intensity. Based on the frequency, they classify again in three categories. First one is the audible, second one is the ultrasonic, and last one is the infrasonic sound. The sound with the frequencies below the 20 Hz, which are the typically not audible to human, they belong to the infrasonic sound. Audible sound. Sound with the frequencies between 20 Hz to 20 kHz, which are within a range of human hearing, so it's known as the audible sound. Most everyday sound fell into this category. Sound with the frequencies about 20 kHz, which are also not audible to human, it comes to ultrasonic sound category. Based on amplitude, they are classified in the two categories. First is the softer sound and second was the louder sound. Sounds that have low amplitude and are quiet, such as a result of the soft sounds. Louder sound, sound with the high amplitude belongs to that category. For example, shouting and car horn. Based on the sources, sound are classified again two categories based on source. First is the natural source. Sound that originated from the natural source, such as a wind, rain, animal calls, known as the natural sound. Sounds that produced by human-made objects or activities, such as a music from instrument, traffic noise, and machinery, come to that category. Based on duration, sounds that last for the longer period without interruptions, known as the continuous sounds. For example, flowing river. Continuous sounds, sounds that last for a longer period without the interruption, known as the continuous sounds. Impulsive sounds, short sudden sounds like a clap, belongs to this category. This classification help in the understanding the characterization and behavior for the different type of sound. Now come to our main topic is the ultrasonic sound wave. Ultrasonic sounds wave are the sound wave with the frequencies higher than upper limit of human hearing, typically above the 20 kHz. These waves are not audible to human but are used in variety of applications. Ultrasonic waves have some special properties like frequency. The number of the cycles of the sound wave that occur in a 1 second is known as the frequency. Ultrasonic waves have the frequency above 20 kHz. Wavelength. The distance between two continuous points that are the phase on the wave known as the wavelength. Due to their high frequency, ultrasonic waves have shorter wavelengths compared to the audible sound wave. This allowed to the high resolution imaging and precise measurements. Speed. The rate of the ultrasonic wave propagate through the medium known as the speed. The speed of the ultrasonic wave is that depend on the medium through which they travel. Typically, they travel faster in a solid, slower in a liquid, and slowest in a gas, similar to the other sound wave. Amplitude. is also one another characteristics. Amplitude determines in the intensity or energy of the ultrasonic wave, but it is usually lower than that of audible sound wave due to the higher frequency. Penetration. Ultrasonic wave can be penetrate deep into material, especially sounds, especially solid, which make them useful for application like medical imaging and non-destructive testing. Reflection and refraction. Due to their short wavelength, ultrasonic waves exhibit less diffraction compared to the lower frequency waves, which help in focusing the waves for the precious task. Absorption. Different material absorb ultrasonic waves at different rates, affecting how far the waves can travel through the given medium. Non-linear effect. Ultrasonic wave can use non-linear effect like harmonic generation, which useful in a medical therapies and other specialized application. Let's know about the journey of the ultrasonic sound and their discoveries. Near the 17th century, the concept of the sound waves was beginning to take shape. Scientists were just starting to understand how sounds travel through the different medium. Year 1880, a major breakthrough occurred when Pierre and Marie Curie discovered the piezoelectric effect. That means the certain material generate a electric charge when the subjected to the mechanical states. This discovery was crucial because it allowed scientists to produce ultrasonic waves, which are the sound wave with the frequency higher than what the human ear can hear. In 1970, the fast forward to the World War I, and we encounter Paul Langevin, who developed the first practical ultrasonic transducer. This device was used in a create sonar, which helped to detect submarine underwater. This was the significant advancement in the technology and had a major impact on naval warfare. In year of 1950, after the war, the technology began to find application in a medicine. Medical professionals started using ultrasound for non-invasive imaging. This allowed them to see inside the body without surgery. In year 1960 to 1970, ultrasound technology also found a place in an industry. It began to be used for non-destructive testing, helping to inspect material and detect flaws without damaging them. In today's scenario, ultrasonic sounds are used everywhere. It is used in a medical diagnosis, quality control and manufacturing, and even in everyday products like cleaning devices. Ultrasonic sound has implied from every scientific discoveries to become a crucial technology in a various field. Its development has significant impact on the medicine industry and everyday life. About sound, the fundamental relationship between the speed of sound, frequency and wavelength is given by V is equal to F into lambda, where V is denoted for where V represent speed of sound in the medium, F represent the frequency of ultrasonic wave, and lambda represent the wavelength of ultrasonic waves. This formula help to understand how ultrasonic waves behave in different media and it used in a various application including medical imaging, sonar and non-destructive testing. Ultrasonic waves can be produced using several methods. Some Some main production methods are piezoelectric method, magnetostriction method, mechanical method, optical method, electrostatic method, electromagnetic, acoustic, transducer method. Today we will study about piezoelectric method and magnetostriction method in a detail, and other is a cover in a very shorter form. Now see what is the piezoelectric method and what is the piezoelectric effect. The piezoelectric method of production of the ultrasonic sound, that is the one of the most common method to efficient way to generate ultrasonic waves. It is utilized the piezoelectric effect. A phenomena is which certain material generate a electric charge in response of applied mechanical stress. Under this effect there are two things. First is the direct piezoelectric effect and second one is the inverse piezoelectric effect. When mechanical pressure or stress is applied in a piezoelectric material, it generated an electric charge. This is the principle behind sensor that detect pressure or vibration. When that phenomena known as the direct piezoelectric effect. When a alternating electric field is applied to the piezoelectric material, it causes the material to deform periodically. It is the frequency of the applied electric field is the ultrasonic range the material vibrates, that the frequency producing ultrasonic waves. That phenomena known as the inverse piezoelectric effect. Piezoelectric materials have different categories like natural piezoelectric material, synthetic piezoelectric material. Some naturally occurring materials such as the quartz. Quartz is the particularly common due to stability and availability. They have strong piezoelectric properties and are widely used in ultrasonic transducers due to their higher efficiency and extraordinary properties. Let us see the construction of the piezoelectric transducer. The image is detailed. This image is provide the detailed information about the piezoelectric method. Let us see their different components. First is the piezoelectric crystal. That crystal saturated in the central part of the transducer. This crystal is the core of the transducer and vibrate when the alternating current is applied. Thanks to the inverse piezoelectric effect, the vibration frequency matches the frequency of the applied AC voltage which can the ultrasonic range. Electrodes, they are attached to the both sides of the piezoelectric crystal. These are the thin metal plates usually made of the silver or gold. They are connected to the AC power source. The AC voltage applied across this electrode create electric field, causing the piezoelectric crystal expand and contract. Backing material, that is the pagination behind the piezoelectric crystal. This material absorbs the ultrasonic wave that are directed backward from the crystal, preventing them from the reflecting back into the crystal, which could cause interference and reduce the efficiency of the transducer. Matching layer, that is the saturated in the front of the piezoelectric crystal. That matching layer help to enhance the efficiency of transforming the ultrasonic waves from the crystal into the surrounding medium. It is the design to match the acoustic impedance between the piezoelectric material and the medium, minimizing reflection and maximizing the wave transmission. Next component is the AC voltage applications. Arrow pointed toward the electrodes. These arrows represent the application AC power source. The AC voltage applied across these electrodes creates the electric field, causing the piezoelectric crystal to expand the material. Last stage for this procedure is the production of the ultrasonic waves. The wave propagating from the crystal into the surrounding medium. As the piezoelectric crystal vibrate, it generates the ultrasonic waves. These waves propagate outwards from the crystal and into the surrounding medium, where they can use for various applications. Application of the piezoelectric ultrasonic transducer using in a medical ultrasound imaging appliances. That applications are using widely in a medical industry that detect the ultrasonic wave for the imaging the internal organ and tissues. Ultrasonic cleaning. In the ultrasonic cleaners, piezoelectric transducers generate high efficiency ultrasonic waves in the cleaning solution, creating cavitation bubbles that help clean intricate and dilated items. In a field of non-destructive testing, in a sonar system also use piezoelectric produce transducer. Submarine and ship sonar systems use the piezoelectric transducer to generate and receive ultrasonic wave underwater that give the permission for the navigation and detection of the object. That have some advantages and limitations also. Some advantages are high efficiency and sensitivity, compact and can be made in a various size and shape, capable and producing the wide range of the ultrasonic frequency, but they have some limitation also, like piezoelectric material can be brittle and sensitive to the high temperature. The efficiency of transducer can be decreases over the time. The performance can be affected of the temperature and the humidity of the operating environment. So, piezoelectric method is the one of the most common and efficient way to generate ultrasonic wave. It utilizes to the piezoelectric effect and phenomena which certain material generate an electrical charge in a response in a applied mechanical stress. There are the one another ultrasonic production method is the magnetostriction method. That method produce the ultrasonic wave are using mechanical way. That is also produce the magnetostriction and the piezoelectric oscillator. In a field of research and development, using the characterization of the material, ultrasonic sound are the widely used, and for the testing of the acoustic emission, ultrasonic sound are the also used. So, dear learner, today we will discuss about the sound, types of sound and detailed study about the ultrasonic sound, their production, application in a various field. Hope so today you understand and enjoy this lecture. Thank you for being patient.